format for the CALFA databases. I haven't had a few feedback, but I have not had very much corrections or, well, there has been some additions which I have not thought about before. Bengt Hallstedt added this crystal structure information one could include in the databases, which I think is nice. What I hope this meeting is that we can actually decide what kind of markup language we will use for the definition of the new CALFA databases. It doesn't have to be XML. I used XML because that was the only one I know. But I know there are other XML, similar languages, and what I understand, one can quite easily convert from one of these markup language to another one. So I don't think it is terribly important to decide which, if we use XML or JSON or some other language, but I think we should decide which we should use. And then if you prefer, someone prefers to use some other markup language, there should be a software available for transforming from one to the other without problem. And then locally one can have one format and then one can transform to the XML format. Because the urgent reason I come into this work on a new database format was that I had to help a lot of people to convert a TDB file from Pandat to use with OpenCalFAD or vice versa. So I think there is a need to try to have a common database format for all kinds of CalFAD software. And we would simplify extending our work to outside the CalFAD community if we can have a generally accepted format for the databases, so people doesn't have to understand why a comma in certain position means something and in another position doesn't mean anything. My hope is that after this meeting today, we have decided a structure, a language for writing things, and then we will still have a lot of work to decide on the kind of what is called tags and what is called attributes of the tags and the information which should be assigned to these attributes. And that will also take a lot of time. So deciding the markup language is the first step, but then we haven't finished the work. We still have to work with the internal structure of this markup language. So I would like to open up now. Anyone who has any comments on the things I have circulated, please, we can ask questions or discuss some things. And then I would like to go through what I have written on this things which I have sent around, and you can raise questions again when I go through that one. And then I hope we can look into what we should try to decide here. Okay? So anyone has any questions or ideas which they haven't communicated by email to me, you are welcome to raise that now.
Please, Ursula.
I have a comment regarding the language choice. You are absolutely correct that there are a bunch of languages that are very similar to XML that could be chosen for the communication. When you propose the suggestion, for XML, my first thought was, why not JSON? And one reason that I like JSON was because it's shorter. you don't have to repeat things at the end of a tag or an attribute. And that's the only reason. Other than that, they are very similar and very easily exchangeable. And at the current point, I would say let's flip a coin between them. And since already the major work has been done in XML, so why not continue with XML?
Okay, thank you. Any other comments?
Yes, my own comment is just the last word that Ursula said, that because Bo has done a lot of work on XML, and I think we should try not to waste it. Of course, I am quite limited about any other possibility, but as long as this group is not too big, of course not too small, I would recommend to go in the direction of person speaking. Okay?
Well, I would argue against Ursula that I like the big ending of the tags. If you have just one tag on one line, you just say slash lesser than, larger than, that's the end of the tag. But if you have a tag for faces, which is 10 lines, then you see a big tag at the end that this face ends. And having just a curly bracket at the end, I found not so easy to visualize.
Well, there are certain advantages to having it more spelled out. But again, it makes things longer, and I like to keep things short, but that's my personal preference. And sometimes I also realize I'm paying the price for keeping things short, that I may go back after a couple of years and look at things and scratch my head and go, what did I do there? So, as I said, you can flip a coin since the majority was done already in XML. So why not just continue with XML, since it's so easy to convert between one and the other?
Thank you. Well, I know Sommerkalk AB does also wants to have short TDB files, but if a company like Sommerkalk distributes a database, they encrypt it, so they can basically use whatever format they want when they distribute it, and because nobody else can read it anyway, so, except the Sommerkalk software. So thank you. Well, if you accept XML, can we decide already to use XML for the definition? Then basically in a year or two, we could change to another format. But writing out, there's quite a lot of tags to be defined. There's quite a lot of attributes to the tags to be defined. And if we do that in XML, then we all know how to handle it.
And I think that's the really more important issue, to get the structure worked out.
Yeah, I agree. Okay, so I continue using XML, and we can all work on that for the time being. That was a big decision I wanted to have this day, but then if nobody else has a point, I will suggest I go through what I sent you, this version XTDB version 4, and you can raise questions while I explain parts of that. You just interrupt and we can look at some details. Is that okay?
Sure.
Okay, then I will share my screen. I share it already, or?
You should use the arrow over there. Here, this one.
And then share this one.
Well, on my screen, there's a button on the top right that next to the leave button that says share.
You will I will help you using the PDF.
Well, let's see, I need to scroll things on my screen.
Yeah.
Entire screen. Allow. So you see my screen, I can see that.
Now we see your screen.
So then I open my PDF. And here, now you can see. Okay, so this is the document I sent around. And I will go through the whole document, and you stop me, and I will try to abbreviate a bit what is on the text. And you say stop, and I can explain something in detail, okay? So this is a kind of background. I hope we could all write a paper together, and I don't know where one can publish it, but at least it should be available for anyone to read. So I hope all of this can be made public quite soon.
Sorry, who said, do you hear me?
Very noisy background.
Do you hear me better?
Pardon?
Do you hear me?
Yes?
Yes.
Okay, so I've not received that version. The last version I had was version 3. Could you check that I was in the list of the people you sent it?
Okay. Sorry.
Let me do it. I would forward it now.
Natalie, did you check your junk mail? No, sometimes at least I have things showing up in junk mail. I have no reason why they went there.
Well, usually Boos's mail, they're right. The all other people that's not.
Well, if I send things via this link from Axel, maybe it appears as a junk mail. I mean, that's the problem of using.
Well, there are many reasons why things can add up in junk mail.
Yeah, but
Natalie, I've sent you to the document now. If you can check your email.
I received a version from Fabio, not from Bosa. From Fabio's email.
Yeah, because I think Fabio may be the owner of the list.
No, not me. It's Axel.
Because
well, we have sent
also from Fabio.
I can write to you.
Okay, I got it.
Yeah. Anyone would need it more? Okay.
Okay, I'll start. We can go back to send I mean, this document will be updated quite soon, I guess, anyway. So, but this is the background. I mean, we want to have a format which you can easily edit, like the current TDB file by a normal text editor. We want to have a database format which can be read by one software, but generated by one software and read by another one, without having to explain why a comma in certain places are creating problems. And we want to keep bibliographic information. We want to include more models in a simpler way. I mean, the current TDB format is very messy for adding even the magnetic model. And so on. That's background. Then I added a section because I'm updating it many times, and I tried to well, in the beginning, I tried to have different colors for different texts which were added, but that turned out to be messy because I didn't have enough colors. So I tried to include things which I think is significant and changes, so one can look at it. But it also means that the document will not be completely consistent. I may make a change in one place and not update another place. And that's something I will have to work through. For example, this disordered part, I have still a new idea how to handle that. So we can see how we can work it out during the day. And I added this aluminium carbon assessment from Malin, and also an TDB file, XTDB file generated by Bengt Hallstedt, where he included this crystal structure tag, which I think is nice. And also this disordered part thing we will have to discuss a bit, because it is differently. We need a database format for it, but then it is handled differently in OpenCalc and ThermoCalc, for example. Okay, inconsistencies. I got this idea from Xiong Ling that one could separate part of the database into another file and have a link from the basic XTDB file to another file with parameters for a certain phase or a certain type of parameters. And I also changed this thing about assessed system and system tag, so that I will come back to that in the actual description. Unary, that is, parameter tags and so on. In the original TDB file, lower and upper cases are treated as identical, and basically in the XTDB file, the XML tags are case sensitive, but the actual data, which will be the phase names and so on, I suggest we still don't separate. I always convert whatever I read from a database to uppercase. So it will be no separation between lower cases will not have a separate meaning. Then Xiong Ling also wants to use parentheses in phase names. I don't like that, but that's something we can discuss. I prefer to have parentheses only for outside the model parameters. And then abbreviations for phase names. I think abbreviation is quite nice, because you have quite a number of oxides phases which has almost the same name, except some mono or para or something like that in the end. And I think it's nice to be able to abbreviate them in parameter names or when you use it in your software. So that's things. Then I don't really know how other software works, but basically I'm using Fortran, and when I read a file, I normally read one line, which will be terminated by a line feed or a line fill character return. And that means I would like to specify that an XML tag should fit within one line, because if it is several lines, one need to concatenate these to extract the information. But it doesn't mean that, if you have a phase tag, that may include other tags. And what should be in one 2000 character line should be the tag itself and all the attributes of that specific tag. Then if there are nested tags, they can be on separate lines. And then there will be a line with the end of the phase tag coming as on a separate line. That's, I don't know. I'm only familiar with how to read Fortran within Fortran. If other languages will have other kind of preferences, you should raise that before we finish today. Okay, this is just how XML works. You have a tag name. If you end it on the same line, you would have a slash greater than. If you have internal tags, they should start on a separate line, and then this tag should end on a separate line with just this kind of end here. You see what my screen? Or okay, I hope. Well, if you don't see my screen, please tell me.
I see your screen.
We see.
Good. Okay, and you see where I point with my little hand. Okay, good. In XML, you are reserved. You have 3 characters which are reserved, lesser than, greater than, and the ampersand. So they should not be used anywhere else. I know, for example, I looked at converting one TDB file with gas phases, and many gas. The bibliographic part of the gas phase usually had the parenthesis, well, lesser than G, greater than, so they had to be converted for something else. But normally these characters are not used in the data part of the TDB file. And then also the equal sign and the upper and, well, double quote is not really reserved, but one should be careful using them not to confuse XML about what is.
I think the smaller, larger signs are used in the SGTE pure substance database to distinguish the gas species from compounds.
Mm. Yes. Well, when I read this, I just converted it to well, not a, well, you can convert it to curly bracket or any other kind of bracket.
You can convert it to anything that you want, but I was just explaining the historical background.
Yeah. Yes, I know.
And I think that's may have started with Barin Knacke, but I'm not sure.
Well, the chemists used a lot of special. They took the whole thing, well, all the possible characters to separate things. And I mean, they don't really different between different solid structures, so it's not so very useful for CalFAD. Okay, and in XML, one has this facility of adding comments anywhere, basically. And you can, as I understand. If you start with a tag and then have some arguments and then have a closing greater than, then you can add comments after that. It seems that XML doesn't bother about it. So,
but when it comes to comments, I think I don't like the casual comments that you have like there. If it's a comment that is really relevant to the database, then I think it should actually be in a tag that's called comment or note or whatever. So it's not really lost, or it's given some meaning. Because, for example, with a tag like the pointed bracket, exclamation point, I could something like there. I stopped editing there on November 5th.
Yeah. Well, I have some examples.
Fine.
Yeah. But I have some examples later on how to use tags, well, comments within the tag, I think, yeah.
But if it's a comment like, oh, I couldn't find any data, so this is my best guess. I think that's an important comment, and that should be preserved when things are moved.
Yeah, I agree. Okay, we come back to some examples. I have looked at this comment line. This is some general tags. I'm not really familiar what one has to give here, but basically one should identify the version of the XML or the version of the XTDB, so the software can maybe adapt to what is allowed in different versions. I realized that I added a software tag which would be useful for understanding how to calculate the binary phase diagram here, but I also had a software here. And this software would be more like OpenCalFAD version 6.58 or something like that. But here one should just specify that it is OpenCalFAD or ThermoCalc or Pandat.
What does the note plus minus mean?
The plus means that it is compulsory. The minus means it's you cannot ignore it, or it can be omitted. Yeah. Omitted. Okay, and then database info. Maybe one should have more specifications here, but basically it's a comment to the database. And then this was the idea from Xiongling to have that you can separate a large database into several files. So you can specify a file name here where you have either some specific information or just to make it more easy to handle on the computer. So I haven't elaborated this, but I think it's a good idea, and I think it is useful with, the largest database I have a copy of is for the TAF ID, which is 41 elements, and I don't know, it's not really so big in megabytes, but it's around 300 phases and 40 elements, so it's quite big. And it's a single file.
For example, I could easily imagine putting something like, if you have the gas phase and a fairly complex description of it, put it in a separate file, because probably once this is worked out, you are less likely to work with it, and it just gets rid of a good chunk of data and makes the file size more manageable.
I would think that one should have some restrictions. I would think all phases should be on the basic TDB file or XTDB file. But then parameters for a phase or volume data for all phases or bibliographic information could go on a separate file. So we should have some restrictions. I think we need some restrictions what you can put on the appendix file, but normally it will be up to
the gas phase in the main file being defined as such, but then, for example, all its parameters, which is the bulk of its description elsewhere.
But I think some rules like that has to be done. Otherwise, it will be complicated for software to the order of reading things or extracting things from the database.
Yeah, we need a file like a master file and an appended file, something like that.
Yeah.
I suppose this can be quite useful when one starts to add all sorts of properties to databases, not just thermodynamic data, but also like electrical resistivity and lattice parameters and I don't know what.
Yeah.
Sure.
Good. It was a good attention. And okay, I don't think we need to, well, I could maybe explain what the nodes are, but we need the elements and we need species. Those are the basic part. And I treat vacancy and electrons as the element here. They will normally be default, I think, but and then it has to have a chemical symbol, and those are from the periodic chart, but you could have a database for fictitious elements also. I mean, not having anything. One should be the reference date, the mass, those are basically optional. we never use them in any Calfat calculation as far as I know. But I remember when we worked on the 1991 unary database, there was some chemists involved, and the chemists said that you need to have the H298 in the database, otherwise it's not useful. So,
well, since it's only for the elements and we are dealing with at the very most maybe 100 of them, I think it's not too much to ask.
No. I think we should keep them, but they are still not really used anywhere.
Well,
the idea is also, yes?
In the third generation, they can be calculated from the data themselves. So,
yeah. At least for the reference state, yes. Well,
yeah.
It depends what you choose as reference state, of course. Yes. Okay, the idea is also that all the elements will automatically be species. So one doesn't have to use iron both as element and define it as a species. I think that is okay. I mean, then, but species are what I consider as possible constituents of a phase. So an element, we may have phases which doesn't have elements as constituents, but molecules. And the molecules you have to define here as a stoichiometric combination of elements. And I said that it should be maximum 24 letters. I don't know if anyone wants any longer names. I mean, certainly there are some molecules which have longer names in chemistry, but I think we can accept it. Stoichiometry, that would be the element identifier followed by an unsigned real representing the stoichiometric ratio. That's based. I think that's how I defined it in the TDB file. And then we have some species for special phases like the quasi-chemical model. And my suggestion here, I don't think, well, this is not something we have to decide today, but for me, when I started implementing this model, I took the whole line from the FactSage database and put that as a MQA addition to this, and then the software will have to interpret that line, because it is, you never know when FactSage will change their format, so one should be able to modify this quite easily.
Yep, but in part, we are talking here about the basic properties of the model that are captured with the XML. So that should not be an issue. And what FactSage then does internally with their software, who cares?
Yeah, well, if you want to calculate with their data, you have to care a bit, yes.
No.
But I think it's nothing we have to do.
A change of model. The basic model properties should remain unchanged as long as the model doesn't change.
Yeah. Anyway, it's something which is a bit particular, and the same for the Uniquac model. I realized they use the volume and the surface area of the molecule as part of their entropy expression. So one needs those two values for calculating the entropy of a Uniquac model. So those are to add flexibility to the software to handle other kinds of models than the one we normally use. Okay, something about this is basically how the TDB file works today. I mean, the vacancy is considered as an element, and it has if you have a vacancy in the sublattice, that will contribute to the configurational entropy. The electron itself is only used as a charge on a real element. So that is given in the stoch. You can call Fe plus 2 whatever you want, but when you give the stoichiometry of Fe plus 2, you can either use Fe / minus 2 or Fe / plus 2. I don't know if I
I don't get that.
Pardon? You don't want it, or?
We should avoid a slash
the minus
2.
minus is basically a plus.
Yeah.
Okay.
That should be avoid. Because is minus in the C++ means decrease by 1.
Well, okay. I don't. I think at least in Sommercalc I accepted this, and I think in OpenCalphite I accept this also. But
Okay.
everybody's using this way of saying minus +2.
I would say I agree with Sean Lin to avoid that, because it basically confused me. I can see now, after understanding it, the logic behind it, but it's definitely not intuitively understandable.
Okay. Yep. Well, I accept we skip this one and only use this one. Okay. And the same if you want an electron, there are some gas models for plasmas where they have 3 electrons, I think. One could use a vacancy with a negative charge to specify electron. Or when we did some semiconductor elements, we had holes, and that would be a vacancy +1. So
Yeah,
one can introduce a positive charge without having a real element in this way. And we skip this one, okay, only this one. So, sorry, I shouldn't take too much time on this, because this is not really part of XML. This is part of TDB file structure. Then this is, I would say, the major part of the database. You will have functions. So, and as I understand, this is quite the way one can very simply translate function in the TDB file using this kind of structure with where you give an identification of the TP function. I put maximum 16 characters. I know Axel said he wanted more because he wanted to put in the whole software name of the data of the software which had calculated this function, and I'm not really happy with that. Anyway, this can be discussed. Then we can, normally we would have a lower T limit, so you don't need to have a lower T limit. If you take the default one, then you have the expression. And it doesn't matter if, I suggest it doesn't matter if we finish it with a semicolon or not. It will be terminated by the double quote. And if there's a semicolon at the end, after the semicolon is ignored, I would say. If there's no semicolon, it's accepted up to the double quote. And then if you have several temperature ranges, you will have a T range tag with just the expression up to the next high T limit and so on.
But I would then make the same apply also for pressure ranges, even so it may be not used at the moment.
The complex thing with pressure ranges is if you have both pressure and temperature ranges, you will have trouble. But yeah.
That's then basically the software is having that issue. It should not be an issue for the file, the database file.
Yeah.
So I think it's almost trivial to adopt the same concept as you have for the T range, to have also the pressure range.
Yeah, yeah.
But that should be
I don't think you, Natalie?
Yes, the pressure range should be inside the temperature range. They cannot be separated.
Yeah, well, I have only worked with pressure ranges once with Saxena, and he didn't bother about temperature ranges. So I mean, I think either you would have temperature ranges or you would have pressure ranges. So I think they are more or less exclusive. Yes.
But if one day people want to have both, you cannot. Well, do we want them to be totally separated?
I don't know, but we can include pressure ranges and say that software will have to handle it.
Now, for example, I'm thinking of the issue between gases being ideal or non-ideal when you have to go to the virial coefficients. As long as you can do them as ideal gases, you can have very simple descriptions. Well, once you have to include, you have to go, like hydrogen, for example, up to 100 atmospheres, you can easily treat it as an ideal gas. But then when you go beyond that, you need to bring in the virial coefficients. And I think if you have a real complex gas phase, then computation time go up. And I don't have much experience with solids, but I wouldn't be surprised if you have similar issues there.
Yeah, I agree. I will think about a way where one can at least have only T ranges or only P ranges. Like that's should be no problem. But if you have both, one will have a bit of discussion how to handle that.
Yeah, but again, that's the software and
Yeah.
should not be an issue of the database format.
Yeah, I agree. Yes. I will add P ranges and also a default low P range and high P range. That's no problem. Yeah. Okay. Then we come to the phase tag. There's lots of things. Well, I will not go through all versions here, but you have a name of a phase, of course. And this is a bit that I allow abbreviations. I think, well, configuration is, I mean, Ceph in most cases. I don't know if we want a specification for an ideal phase with only ideal entropy and no excess terms, or Reddish-Kister excess terms, but those things are more on the application side. We need, I've added a state here, because if we use the equientropy criteria, then you need to have an identification of which is the liquid phase in your system. For the other ones, it doesn't really matter. Then this is, I changed, originally it was sublattices here, but I changed to sites because one thing I don't like to talk about sublattice for a phase without sublattices. So, and then number of is the number of sublattices. So if you don't have any sublattices, you don't need this one. But then even if you have only one set of sites, you should identify how many atoms are on these sites. So I think you need this multiplicity, even if you have.
Now the question, will that translate then to what we are calling now sublattices, or is it part of the crystal structure description? For example, I'm thinking of the sigma phase. I have 5 sites, but I can do it with 3 sublattices. So what would be, if I do the sigma phase with 3 sublattices, what would be the number of B there? 3?
if you model your sublattice sigma with 3 sublattices, you would have 3 here.
Then I would call
you
it
would
still
have
the tag sublattices.
Okay.
And then I would almost, okay, I have another idea for the crystal structure. But let's stay here.
Okay, well, I'm open. I thought sites were more general than having sublattices here, but if everybody having, except that we have sublattices when you have a single sublattice, then okay for me. I mean, we have used that for 30 years now, so it's okay for me.
I started my scientific life as a crystallographer. And for that reason, when I hear sites, I really think in terms of Wyckoff sites. And in Calvert, I may combine multiple sites into one sublattice. So I think by using the term sublattice, you make a distinction. And particularly if you limit the number to 10, for other TCP phases than the most common ones, like the P, the R, etc., 10 will not be enough to describe all its Wyckoff sites.
Yeah, I know, yes. Jean, I got a request for having 14 sublattices, so I haven't implemented that yet. Okay, well, I'm happy to go back to sublattices. I used that for 30 years, so it's no problem. Then this is what was suggested by Bengt, that you could have a crystal structure information. I don't think it will be used in any CalFAT calculation, but I think it's very good information to provide to external world anyway.
And I agree with that. But again, for example, prototype, it should not, the crystal structure should be actually an outside of the phase part. Because because
well, we come to the example. I have some examples from Bengt, and we can discuss when we come to that part.
Okay. Okay. And actually, there I would make the sites, the Wyckoff sites, as part of the crystal structure specification. For example, going back to the sigma, there I could now put down that it's actually 5 sites, and could also use the Wyckoff nomenclature. So it would be, for example, sigma 2A, 4F, Okay, and then 2 times 8I and HA.
Yeah. Going back to the sublattice part, if you look for the BCC phase model with 4 sublattices, you would actually like to identify which 2 sublattices are next nearest neighbor or nearest neighbors, because you will have parameters which relates to that. So,
but that's fine there. But again, I would still make it a sublattice description to, because the crystal structure actually doesn't care how you set up a model.
No.
So for that reason, I would like to have the 2 somehow separate. Crystal structure, really how the crystal structure is, and then the sublattice, how we translate it into a CalFAT description.
I think.
Yeah, well, I think the idea of having this tag here was that you wanted to include it in a bit. Well, one had to include more information relating these 2. Yes. Yeah.
Do you hear me?
Bengt, do you have any comment on?
Well, not really. The purpose for me was just to have this as an information, and by collecting this information, you have an idea. For instance, if you have two faces with the same crystal structure, you may in the future combine these two to one face or something like that. So it was not really intended for, let's say, for quantitative purposes, let's say, to actually use in the software.
Reza, you had something?
Yeah, I think about the Wyckoff sites, ideally we would want to map the sites to each sublattice. So for example, for sigma, you need to, if you use 3 sublattice, you need to specify which Wyckoff sites go to each sublattice. That's better.
Yes, well, as I see it today, no software would use this information, but I think it's for the future. It would be nice to relate how people have done it. Yes.
We do have
Sorry,
some sort
Axel
of
here.
internal format.
Soon enough, software will use that site. I can tell you that.
Who was that?
Sorry, this is Axel van der Waal.
Yeah.
So yes, the idea to have crystallographic information in the file, I think, is great. I mean, it's really fantastic. I think that was missing, and I would. You say no software will use it. Well, maybe some software will use it.
We are already using it.
For CalFat purposes, once you are done with the database development, I think it's really information only, but it's nice to have.
Yes, that's the point. Even if the software doesn't use it, the user is happy to get this kind of information. Well, some of it.
Yes. Okay. Well, it's something new from this XML feature because, well, you can always add it as comment in the TDB file, but this way one will be able to keep it inside the software also. Yes. Okay. So then constituents is related to the sublattice up here. For each sublattice, you specify which constituents you have in the sublattice. And the list here consists of species identification and separated by space. And it will be one constituent tag for each sublattice. In the current TDB file, you have a colon separating each sublattice, and you have a comma or a space between each species. And this makes it easier to handle, less problematic, not to have to. Well, in the TDB file, you could have a comma or a space or a semicolon after a species, and you have to handle that separately. This would simplify a bit. Then comes this amend phase, which replaces most of the type definitions. So here you can specify magnetic things or other properties which should be added to the phase. And it will be discussed later on with the models. Then there is a model which is a bit complicated. This when we have an ordered sigma phase or ordered FCC phase, where the Gibbs energy expression in SOMACalc or in OPE is separated into 2 Gibbs energy expressions which are added together, and that was done in a very crude way some in the 97 I think it was programmed when we worked with Imo and Natalie for the FCC ordering. So I have varied a bit how this should be handled in the TDB file or in the database file for the XML. And my suggestions now is inside the ordered phase, you have a disordered part. And in that disordered part, you specify either the name of the disordered phase, so you know which one you should add the Gibbs energy to this phase. And you specify how many sublattices in the ordered phase you should sum up to have the disordered composition of the phase.
Okay,
And there
now,
are two, pardon?
okay, now I'm confused what the H and I means because it's neither a plus nor a minus.
Well, H, basically the comment is here. You have to specify the, well, I don't remember what H means
No,
for the moment.
in
Well,
part,
H means,
if it's mandatory or not, then
well,
it
it's,
means that there's no space where I can put an H or an I.
H.
You understand what I mean?
Well, the H here is a letter which comes later on in the explanation. So
That's just
it says that
index. Yeah, just index. I remember.
it's a note
Yeah,
here.
it's the same
It's
with
a
the
note,
F
yeah.
and the G. It should be not a node, it should be something like an attribute.
Okay. Yeah. Well, F and G has nothing to do with the XML. This is just that this attribute here has a note F later on in the text here. And that explains a bit more. I didn't want to put the full 5-line explanation here. So I just put an F here, and then the F here means that it says that you can abbreviate face names, and it should start with the letter A to Z, and it can include underscore and minus signs or whatever. So I agree, it should be maybe an attribute here for the. Sorry for the syntax here, but ignore what it says. This H and I, which
it's fine. It's only in a final document. I think it really needs to be clearly identified,
yes,
because otherwise people will get lost and you will get something that doesn't make sense.
Yep, I agree. This is a kind of well, I was fighting with LaTeX to have a structure which could be in an orderly way, you know. Well, anyway, most of the information is said here, and well, my idea now is that we should not have a disordered part here. I should have a disordered underscore 2 part, and that is without the Y, and underscored with 3 parts, which would be this expression. So I would suggest to have two different distinctions of. Because this was the original model when you had the ordered FCC phase, the disordered FCC phase, and then you subtract the ordered one as disordered. And that meant that you could assess the disordered one separately. You had the data in the copper gold, for example, you can fit the FCC phase disordered. And then you can add on the ordering to get the 3 L12 and L10 zeros. And that would not affect, if you did it like this, those parameters had no influence on the disordered state. Then Nathalie started working with sigma phases, and the ordered part, she used the same technique, but then the disordered sigma phases contained only the lattice stabilities for the pure elements as sigma. Then you didn't want to subtract those, and so it's for the modeling of the sigma phases, you just added the disordered and the ordered one together. So that was the interest of having this subtract here. Okay. Yes, not Ursula.
Well, and still in both 1 and 2, the disordered part has the lattice stabilities of the pure elements, and the ordered parts have the formation energies.
Well, in the sigma phase, you would have the pure chromium as sigma.
Yes.
And here you would have you only need the energies of formation of the different sublattice relative to the.
Exactly, and the same applies to 2. For example, let's do the FCC ordering. I would have the FCC values in the disordered part, and again in the ordered part, I would have the ordered end members.
Yes, but relative to the. Relative to the pure elements, yes.
Yeah.
I mean, yeah.
But the ordering energies here are not the formation energies of the ordered phase anymore. They are different.
In basically, if you have it like this, it means these are excess parameters. They are relative to the pure elements in that structure.
Well, you can name them what you want, but I think the point that I try to make, for the pure elements, you have the lattice stabilities always in the disordered part.
Yes. 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 You will have the Gibbs-Endio formation of chromium in sigma or FCC in this part. And here you would have the formation of the ordered structure relative to the disordered part. Yes. And this subtraction was just that all the excess parameters you had here would not influence the disordered part.
You say formation, and like Wang said, it's not formation strictly, because if you have some interaction parameter, actually it's ordering only.
Well, I think we are now going into the weeds of the models, and that's not the point here.
Well, anyway, the intention here is to be able to specify those two equations, okay? And as a comment, in ThermoCalc, you would describe them as separate phases in the database file. When I wrote OpenCalFAD, I said that was not really interesting, so I allowed the parameters to be written together. So they have both the ordered and the disordered one appears in one single phase description. So. But that can be handled with this structure, because in the disordered part here, if there is no phase name here, it means that the parameters are included in the ordered phase.
Well, so, I think that would be the beauty of the XML, as long as what belongs to the disordered part is identified clearly, and that's a necessity, then the individual software company can do whatever they wanted. They can make it a separate phase, or can make it an integral part of the phase.
Yes, the intention is that one could use both softwares or can handle this. Yes, in the software part. Yeah. Okay. Well, parameter, that's the second most important part of the TDB file, or the XML file. Here you specify the parameter, and you have an expression exactly as the TP function, but here this expression is as part of the parameter, and you can refer to functions inside this expression, of course. And here you have a bibliographic reference. So one should always specify the origin of this parameter, where it was published, or if it was estimated, or if it was just a great idea you had for how to get this parameter.
Now, a question when it comes to the parameters and actually also the functions. ThermoCalc allows only simple functions. So if you have more complex functions, then you need to create a function, and then this function needs to be used in another function, and maybe even another function, depending on the complexity of the expression. And also, there are only integer exponents allowed in ThermoCalc. So, for example, I was recently asked, how do you do the square root of temperature?
That's
yes,
no problem.
there's a
well, you have to define
workaround,
3 functions for it, yes.
There's a workaround, so you make the exponent of the logarithm of half of the logarithm, and you are done. But the question is, what will be the rules for the XML?
Well, I prefer to keep the one for the TDB file, the same. It should be very simple expressions.
Okay. But I think that also must be clearly defined.
Yes, it will come later on. It was one of the comments later on, yes. But I don't expect, I mean, when I wrote it in Samocalc a long time ago, and which has been rewritten in the more modern languages, and when I programmed it in the OpenCalFAD, I used very simple expressions here, just a polynomial in temperature and with integer exponents. If you wanted some more complicated, then you had to separate it into a number of functions, which calls each other. We don't, I think it would be too much to ask future programmers to write whole mathematics expressions here.
I can just comment that the new ThermoCalc core supports all kind of complex functions. These limits are mostly coming from the old Fortran code. So when we switch completely from the old core to the new one, all sort of functions will be allowed.
Okay, that makes it, well, more difficult to be compatible with the other software.
Well, then it would be basically the task for the translation program to sort that out.
In a way, yes. Okay, let's leave it for that. When I started learning XML, I got some help from Richard, and he's proposed a more complex way of having parameters where you would separate out, well, I have an example, I think, here. In this type of parameter, the identification here will be exactly as it is in the TDB file. You would have the identifier of the property, and then the face, and then the constituents on the sublattices, and then you have this degree of the parameter. So this would be exactly as it is in the TDB file. In this example I got from Richard, he had separated out the model identifier as one property, and then the face, actually, and then the constituents on the different sublattices. Maybe I forgot them here. No, okay, then you would have a subtag of this parameter, where you specify the constituent on this sublattice and the degree, and then you have okay, well, I haven't really used this, but I don't. If anyone wants to edit a file like this manually, you don't want to really separate out G on one line, liquid on another line, and then for each constituent specify. I mean, you will have a whole range of tags instead of just this identifier. But
well, for me, that is a little bit confusing. At the moment, I wouldn't know what to do with it.
Yeah. Well, it's for software, it's no problem, but I agree for manual editing, it would be not so nice.
It's at the moment, I would say, if I don't know what it does, throw it out.
Okay. Well, I can keep it as suggestions. Yeah. We also have a problem. Yeah.
It should be better specified what it does and what the purpose of it is. Yeah, that's mainly. I'm liking. I'm not seeing the purpose of it.
I don't particularly like the parameter 2 expression either, but I think the purpose is that you can do more checking on the XML level rather than on the software level.
Well, I don't see that either. But we can postpone that.
Yeah. Okay. I suggest also, I haven't really thought about this. I just kept it because it appeared in the things where I learned to use how XML works. Okay. There's one problem also which I will come back to, is how to handle the wildcard. I mean, in some parameters, you don't specify the constituent on the sublattice, and that has to be handled. I don't think all software does the same way at the moment, so we have to be careful about that. Okay. Bibliography, nothing particular. For each bibliographic ID you use for the parameters, one should specify origin of the value, the number. Then comes the model tags. This is something new. In the TDB file, there is nothing specifying really how the models handles. I suggest that we should have a separate file where we define our models with a reference where it was first described, or the current version is described, and also specifying what kind of model identifiers this model requires, like Curie temperature or Born magneton number. And this is for the magnetic, which we already have. This is something new we have this permutation. When you have FCC with 4 sublattices or 2 sublattices, some parameters will be identical independent of which sublattice certain elements appear. And that I call the permutation of the parameters. And for 4 sublattice models, this can reduce the number of parameters quite a lot. So the number of parameters you need in the TDB file or database file. So I think it will be used very useful for the future also. This, if you have a 4 sublattice FCC model, when you have iron, aluminium, 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 it doesn't matter which sublattice the iron is placed. All these 4 versions will have the same parameters. Otherwise, it's not an ordered phase. So this has to be handled by this kind of what they call permutation model. So it should specify, that should be specified with the phase. Okay, these are other models. I will not go through them. I mean, this is basically the same type. For an Einstein model, you need log the Einstein parameter. You have an Einstein model parameter included in this phase. And for the liquid 2-state model, you have a parameter for the Einstein low temperature amorphous phase, and you have a parameter which specifies where this actually specifies the real liquid. The Gibbs energy for the liquid phase would be the amorphous phase, which is a bit inconsistent maybe. The EEC model, I don't think it will be used very much, but it applies to the whole database. It doesn't apply just to. It is something which should be checked. If a database uses the EEC model, that means you have to check it for each calculation. Okay.
I'm sorry to interrupt.
Yeah.
Is there any interest in having a Debye model in here in addition to Einstein?
The Debye model.
Axel, we cannot hear you.
Sorry.
I couldn't hear you.
Okay. Is there interest in having the Debye model instead of the Einstein, or in addition to the Einstein model?
No.
Well,
we don't want the Debye model.
You basically could do the same as you do for the Einstein for the Debye in analogy, but for Calvert purposes, the chances that it will be used are extremely slim.
We use multiple Einstein instead. You can have multiple Einstein temperatures.
That's actually how
it's just nice if it has, there's a single Debye temperature that fixes a lot of the temperature dependence already. So that's kind of more parameter cheap than many Einstein models. But anyway,
Well,
I don't think I can change the tide, but
if you write a paper proving this, we can be interested. Yes. Okay.
I think, but just for the sake of completeness, I think it might be worthwhile to have the tags, even so they are not likely to be used.
Well, if I might say a word, why not to exclude it totally? So, like you told me, you can include it and then use it. I agree with you.
Because, for example, Irina Vasliakova, she did kind of Einstein modeling, Debye modeling, and she reports the Debye temperature, but then when you ask her how she did it, what kind of lookup table she used, she said, oh no, I used multiple Einstein functions. But I think just for the sake of completeness, it's worthwhile having it. And you just parallel it. So you don't have to implement it in your CalFET code.
Okay. Yeah, yes, I agree. We should, well, this was not a paper where I argued for the models. This was just to have the models which we have decided to use. Okay. So we only use the Einstein model for the moment. Toop and Caller, nobody's using as far yet, but I think it would be nice to have them provided for. But they will not really be belonging to a phase. I mean, Pelton wrote a nice paper 2001 where he said that one could have a Toop model for each ternary subsystem of a phase. So I think that could be. I implemented that in Chamocalc, I think, once, but I haven't done it in OpenCalFAT.
And if I'm not mistaken, what I understood from the FactSage people, that's actually how they handle it in the databases.
Yes, yeah. I mean, it was for FactSage. He wrote the paper, and I found the paper very nice, but it's a bit complicated to handle. But one can do it also with the normal software.
Yes, and I always have Leo Lucas' comment ringing in my ears that says, "What's the hype about it? You just use ternary parameters to compensate for it."
Well, the extrapolations from the ternary will be different.
Yes, and basically, actually in Stuttgart, I had a poster in my office where he showed, yes, you use the different extrapolation formula, but then you take ternary interaction parameters and they start agreeing again.
I mean, if you go to a 5-component system, you will have if you have more used Caller and Toop or ternary parameters, you will have slightly different.
Yes.
But nobody has any data for the 5-component systems anyway. So.
Anyway.
Yeah. Okay.
Well, we can't say that in the future. I mean, it could happen, right? That people have more accurate data for higher order system eventually.
Nobody's doing experiments today, so there will be no experiments.
Okay, there may be calculations. I mean, not.
Well, I wouldn't trust the 5-component DFT calculation, okay?
Okay, well, this is not an argument. I mean, come on.
No,
why,
the problem.
Why am I here? I mean, everything I've suggested has been shut down and say this. Nobody does this. So, you know.
The problem is not having or not experimental in 5 sublattices, but we never have for all the 5 sublattices, the 5 components. Like there are some elements where we have data and others where we do not. And so we do need to have models that extrapolate not too badly in the system when we do not have data. So if we have to choose how the Toop has to work in each of the ternary, it means that we do need to have some information on all of the terms where we have to choose which extrapolation we have to do. And that's already some work in each of the systems. That can be many. Have you been listening?
Yes, we hear you.
Sure. Yeah.
Well, I agree. We are maybe simplifying things, but I would again say that what I'm mainly trying to do here is to find a better way of describing existing data, including also the new unaries. For the Dubai model, I agree, we can include it and let the software decide what it should be using, how it should be handled. For the caller and took model, I think it's a nice thing, and it is not difficult. Well, it is a bit tricky to implement, but it could be done, and it doesn't change the rest of the software.
Oh, that was one question. You always have the modified quasi-chemical in the quadruplet approximation. I don't know whether you would have to do anything specific for the pair approximation, because that's what the majority of the MQM assessments are actually are.
Yeah. Yes, well, the MQA model is identical if you don't have the binaries are identical, I understand, from the old MQM model.
Okay.
Well, it's in a way, when we did the ionic liquid model, we were very happy to find that we could use the old liquid descriptions from the without any cations, without any anions.
Ursula, are you telling that only that the base is with the same anions are actually used?
I really don't know. I would not have known that if Busse would not have explained that at the moment. I only know when I read the literature and I see papers being published by people who are using the MQM, that most of the assessments are actually using the pair approximation.
Yeah, that means the pairs between the cations.
Yes.
But then when you mix oxides with fluorides, that sometimes you need also to have interaction between the anions.
Well, not necessarily, and well, as I try to understand the papers by Arthur and co-workers, they were very carefully developing the entropy expression so that it should be possible to use what they have done already for the MQM model without any changes.
I'm not that fluent with these models, so I cannot comment on anything other than what I just said.
Okay, well, I should try to finish this, and I would like to come to some examples. I had the idea of, I mean, in thermocalc databases, you have this assessed systems where they include a way for thermocalc to calculate the binary, which is a nice feature. And then Bengt and well, myself also, normally I arranged in a big database system the parameter system by systems. I mean, for a binary systems, you have parameters for all phases where this binary has been assessed. And I think, well, that's mainly on the way you manually edit your database if it's a large one. And so I have included possible tags saying unary systems, and then you specify which element it is, and then you can specify the main bibliographic references for the unary. Normally it would be 91 Dinsdale, but for binaries you could have maybe several papers which had done different phases in where those two elements dissolve in phases which may be not stable at all in the binary itself. But so this is a way of organizing information in the TDB file. And you could, normally each parameter should have, well, each parameter should have a bibliographic reference, but when you read the database with ThermoCalc or OpenCalFAD, you get all references which belongs to those elements you have selected. And here you could maybe reduce the number of references so you don't get estimated by Busse 92 or something like that. So you can ignore some references which are not really just for internal use.
Yes.
And then for the binary systems, you could have a command tag here, which would for a specific software would calculate the binary phase diagram. And this is of course software specific, and that is referred to what you gave in the beginning of the database, that you could specify which software one should be able to use this for. So ThermoCalc would have one way, ThermoCalc, OpenCalFAD would maybe give another way. Pandat would give another way of calculating the diagram. Ternary, well, you don't really know what there are many phases, many ways of calculating a ternary system. So I guess that's not so important now. But this was taken from, I think, well, one of Bengt's files for the cobalt carbon system. You'll see all the phases which has been assessed with the cobalt and carbon, and some of them are not stable in the cobalt carbon system. So it's and here you could extract the most important references rather than having all the ones which are for the individual parameters. So this is.
I think that is much in line with the comment from Lina Kjellqvist, where she found that there is too many references for coming out when you pull up the data. So
yes, it was Lina who suggested this. Yes, that's right. Okay. Well, this is a way you can find in ThermoCalc databases how to calculate. This is abbreviated commands in ThermoCalc. This is something which I haven't thought about much, but in at least some of the databases, one has commands creating. If you read iron, titanium, carbon in the steel database, sometimes you automatically create a second FCC phase, because you would have an austenite phase and you would have a titanium carbide phase, which are the same phase. But this is something we can elaborate a bit more when we have worked on this. I think you may even want to have separate names for the carbide and for the FCC phase, but then you have to check the composition of each constituent set, which one is what. So this is nothing we have to discuss today. I mean, it's something we can add on later on. Here comes the notes. Let's look at H. What is H? H was for the phase. So this is a bit more explanation what is the disordered part. So if you have a sigma phase with 3 sublattices which has a disordered part, then you could have the Gibbs energy for the chromium sigma would appear in the disordered phase, and then it would be all the parameters in the ordered one would be referred to this one. So they are basically a kind of excess parameter for that. In ThermoCalc these would be two separate phases, one called dis sigma and one called sigma. And in OpenCalFAD, I added, kept them in the same phase, but of course, for the disordered sigma, I would just have one sublattice, and for the ordered one, there would be 3 sublattices, or 5, or whatever you would have modeled it with.
So would it be possible actually to think about not giving the D because it's redundant with
I agree, it is redundant. I can remove it. I added it because
we can make it in the XML format, and then if the software needs to have it, you can add it.
Yeah, I don't need the D. I mean, it's I added it before I thought enough about it, but yes. Okay, so the notes higher up are explained a bit here. Okay, then the mathematical expression, as I said, I think we should try to keep it simple. So the way it was defined in the TDB file, you had basically terms like this where you had a real number. You could multiply that with a function name. You could multiply that. Well, you could raise this function to power, which was took some time, I remember, to implement. Then you could multiply it with the temperature and the power and the pressure with the power. And then an expression would be a sequence of such terms. So it is basically, you don't need a high quality function cracker to implement this kind of expressions. That I think is good for having high speed calculation, to make calculation at a high speed. Then you can allow this I call the simple term, I think, and then you could have a simple term multiplied with the logarithm of a simple term, or an exponential, or actually error function, I think, also implemented. Originally I implemented log, I think, but then everybody using ln for the natural logarithm. So basically these are the same. And we have added one more function now, which is the Einstein function. I didn't really like that we added this 1.5 r theta, because that is not really the Einstein. That is an integration constant. So this is basically the integrated Einstein function. So this is implemented as a function you can use in a TP expression. That means you can have multiple Einstein functions in your expression. And this is the way to have a square root. You define 2 functions like this, and then you have because you are not allowed to have parentheses like this. You cannot multiply 5 with an expression or anything else. It's just a sequence of simple functions. So, well, this is basically software stuff. Then wildcards are a bit more complicated. It depends a bit how they are implemented in the software, of course. When I implemented it once in ThermoCalc, if you had an expression like this was treated as a parameter, separate parameter. Then you could add another parameter like this, and that would be separate from this one. But I agree that in some software, if you have an expression like this, maybe you made multiple instances of this for all the possible elements you had on this sublattice. You created a parameter which would be like this expression. And then if you wanted to have another expression where you had a specific element instead of the star here, you would need to replace one parameter with this one. So that is a complicated procedure.
So
And it may, yeah.
basically, the way it is currently, it makes it additive. So
the way I've done it in OpenCalFAD and the way I've done it was done in Thermocalc when I was responsible is what those two would be completely separate. Yes, so they will be added
separate,
together.
But basically, when you take it, ultimately, if you would spell them out for each of the elements, all the elements would be 100,000, but the tantalum itself would be 70,000.
Yeah, yeah.
And somehow I think if it's made clear, otherwise the asterisks, if you make them separate, then you would basically have to take them apart separately in the software and then replace the tantalum parameter with the with the one that is explicitly specified. You know,
well, well, this is software dependent. I mean, when I implemented it, I thought this was one. All the wildcard parameters were, treated as one kind of parameters, and then if you added a specific one which overlapped with the wildcard, that would be, completely separate. But when you read this, yeah.
I think it can start confusion how it's handled, because when you just see it and without thinking how it could be easily handled inside the software, it's really not clear whether it's an independent separate parameter or whether it's basically an additive modifier.
Yeah, well, I agree. I didn't think that way, but I agree that it is possible to interpret it in both ways. Yes.
Yeah, and all it needs to be made clear, and maybe rather in that instance use it at, for example, to have an attribute to the G that it's a modifier rather than a standalone parameter.
Wow. Okay.
Just a thought.
Yes, I agree. We have to think about this. I implemented my way, and I didn't think about other ways of doing it. So we should either adopt one way or try to handle options. Yes, because last time we discussed, we had another option again. When you had multiple sublattice sigma phases, the number of wildcards can be quite large. So we suggested that one could have a parameter like this. So you don't give a constituent per sublattice, but you said the constituent and then you specify the sublattice. So if you wrote it like this, it would mean the same thing as this one. And then we are getting maybe a bit complicated things. I don't know.
I think there are advantages to both ways.
Yeah, but we have to define how the software should treat this. Yeah, okay. Because you could have this intention and then you could have one with the same constituent plus something more. So if one of the stars here would be a specific element, then you have to separate how this should be treated from when you have one more element here.
Okay.
I have a comment here.
Yeah.
For those stars, we cannot expand that within database, because if you expand that in a database, which means you have duplicate definition, right?
Yes.
Yeah. So that's a rule here. You either use the star, and then you use one separate independent one, just add on to the star. That's okay. And you cannot expand the star within the database because otherwise you have a duplicate parameters, identical one.
Well, if the way I would store this in OpenCalFad, I would store it so I know that this parameter should be multiplied with a fraction of chromium, and it should be multiplied with a fraction of iron, and then ignore anything else in the system.
Okay.
And then if I had a third one, which are chromium, wildcard, iron, and then molybdenum here, that would be a completely different parameter.
Yeah.
Stored somewhere else. So they would be added together. So
one possibility would make it explicit that when you have the wildcards or anything additionally specified would become additive, like you had in the previous example. And that would be an explicit default that cannot be changed.
Well, we should write something more definite about this and circulate so we can agree what it would be. Either that we have to allow, have to have some kind of conversion depending on which software you use for reading it, or that each software should be able to handle one specific way.
Well, and also one thing we need to realize, once we have the first version that we are actually going to use, it will not be the final version. Because as we are using it, we will be learning.
Yes. Okay. Well, this then also in SummerCalc, when we implemented the ionic liquid model and have only a neutral, basically that is independent of what you have in the cation sublattice. And in the way it is in SummerCalc, you identify this parameter in this way. So you don't give any cation. But when I implemented this in OpenCalFad, I said, okay, there is a two sublattice, so I ignore the sublat. It's independent of the constituent of the first sublattice, so I have a wildcard there. It's mathematically, it's treated exactly the same way. It's just that in the database, I always have to modify. Well, I can read this with OpenCalFad, and then, but when you write it out from OpenCalFad, you will get the wildcard here. And if you use this notation, one should have just carbon in sublattice 2 here. So it's just we should find a way to handle this, because it's a bit inconsistent to have both these two notations.
Yeah, I like the format with the wildcard because it's consistent. Yeah, for us maybe we understand, for some new young people, when they try to read work on the database, they will be confused. Yeah, if we without the wildcard. Yeah.
Bit confused by the last sentence.
This one or what?
Note that interaction between neutrals with a single specific kata. Oh, okay. Sorry. Never mind. I got it. Reading out loud helped.
Yes, it's a bit abstract, yes. But we have, well, liquid carbon is not really stable, but we need a parameter for it.
I kind of like the SummerCalc way of writing it, because the number of sites on the first sublattice is actually 0 in this case. So
yes, that's right. Yeah. Yes, that's why it works. I mean, that's. Well, again, this is something we can discuss. because it's not, it doesn't have to, well, it's model, it's more software things, yes. Okay, well, that was basically all the tags and attributes of the tags, which we, well, you have recorded all of this, Fabio?
Yeah.
So, well, I haven't really made so many notes while we've been talking, but there will be, I will try to work out things which we have agreed and things where we will still need to discuss things. There is this model parameter identifier, which, I mean, Gibbs energy for Gibbs energy, Curie temperature, and so on. I don't like to have too long these model parameter identifiers. We have, the largest we have in the current is Bmagn. And Bengt, for example, always say BM. He ignores the last letters for that. So I think we should not having too long names for the model parameter identifiers, because if people start using abbreviation of them, maybe we will invent a new model parameter identifier which will be as the same as this abbreviation, and then we are in the problems. So I would like to have maximum 8 characters for this one. Well, even 4, but 8 I can accept, but not longer, because this will take a lot of space in the database also. Then, well, we have more models to consider. Cluster site model, I mean, Pandat, you may be interested in having a database with those parameters. I haven't, no experience of that model. Error handling, we should discuss with the software groups. Okay. Points to discuss. We have semicolon. I think we can, it doesn't matter if you finish an expression with a semicolon or not. It's the final double quote is the end of the expression. The gain function is being implemented in SummerCalc now, I think. So it's it means it's trivial to have multiple Einstein temperatures describing a pure element. Redlich-Kister term in Pandat also understand the Redlich-Kister terms if you have the order of the elements in the excess parameter. So if you have b comma a, it means you will have the fraction of b minus fraction of a, whereas the way SummerCalc or OpenCalc would treat this is always to use the alphabetical order. I don't know if that is very important, but one could have a kind of default attribute that Redlich-Kister order is actual. So then if you find this one in the TDB file or the database file, you would actually use this expression, the difference between B and A, or than A and B. You have to sign and change the sign of all parameters.
I know that FactSage uses the actual order, and that has led to some complications when you translate databases.
Yes. Yes, I mean, I think, well, I would suggest that if you want to keep this separate, one would have a kind of default attribute like this, and then the software should make sure that it takes care of this, the difference. Okay, then the disordered phase, I will send more information about how I want to handle that one. I don't like this subtract, but I don't need, I have to think a bit more about. I have nothing against having the L for an interaction parameter. But we shouldn't use L for the end members. I mean, I guess OpenCalc, if you use L for all the Gibbs energies, is okay. So maybe one should change that. Okay, we go back to sublattices. Okay, no problem. There is also, I don't know if everybody agrees, but when you calculate for a temperature outside the range of your parameter or a temperature function, in OpenCalFA I use the expression from the range which is closest. I mean, if you go at a high temperature, above the high temperature limit, I would still use the same expression, just calculate at the high temperature. Or if it's below the lowest temperature, it will still be used the expression which is closest to that range. Does anyone have an opinion about that?
I think that's okay. Having an internal flag is a good idea because then you could check afterwards if someone was outside the sort of intended ranges.
I think in SummerCalc it's implemented, but I never check it. I think for a simulation program, it might be nice to be able to check if they have actually calculated outside the range of the database. So it would be a software tag which you can call and check if there's been any problem.
I think
what do you mean internal flag? It's
a global variable inside your software, and it should be 0. But if you have calculated outside the temperature range, you change it to a number, and if it's a number, then you have some information that you have gone outside the range.
How do you tell that from your result? For example, you calculate phase diagram. How can you know
No,
that?
you don't see it. You don't see it. But your software, if you have any time you make an equilibrium calculation, you can afterwards check if this flag has been set. If it has not been set, everything is okay. If it has been set, some parameter has been calculated outside its temperature range. You don't know which one. But you know that some parameters in your calculation has used the temperature outside the range.
Okay.
It's not, I mean, it doesn't tell you very much, but it tells you that at least one parameter you have used in your calculation has been used outside its temperature range.
Can user know that, or only developer know that, access the flag? Who can access the flag?
Well, I'm thinking now myself, I actually don't know. I don't think I even bother if this parameter is for one of the stable phases. So it's a bit, maybe a bit too wide.
Okay.
Yeah.
Okay, that's fine.
Well, anyway, I think one should not give an error. I mean, you should just, in some way, be able to check after a calculation has been made if any parameter has been used outside its temperature range or pressure range or whatever. Yeah. That will then you have to look at the parameters on and see which one might be problematic. Well, that's it. I will look at some of the examples. This is not really. This is the way for MQA they give a number of numbers related to the charges of those. So my suggestion is that we take the line which is in the DAT file, which specifies those things, and then that is used for calculating the stoichiometry of the phase of the constituent. This 2.4 is a kind of SNN, short range nearest neighbor, and higher free nearest neighbor. Yes, I've forgotten all the terminology. There was something I wanted to. This is how we express, for example, the Gibbs energy for carbon as graphite. You use a gain function. I haven't updated this one. No. In the current version, we use the actual Einstein temperature here. In the earlier version, we took the logarithm here because the logarithm is just the logarithm is what is used for. Sorry, I don't have the parameter here. For the liquid. Sorry, this is. The Einstein function for the carbon in graphite, it has 5 Einstein temperatures, and actually in the current version of some OpenCalF and thermocalc, this argument should be the fitted Einstein temperatures. So the values you see here is the logarithm of the Einstein temperature, and that was used because in the parameter for the Einstein temperature, Göran Grimwald said that it is better to have the logarithm of the Einstein temperature as composition dependent, because if you vary, this represents almost 2000 Kelvin, and if one is 300 Kelvin and another one 2000 Kelvin, the slope is too strong. So one should use the logarithm of the Einstein temperature as composition dependent. And then in the first version I implemented here, I used also the logarithm in the gain function, but now we have the real Einstein temperature here because this doesn't change with composition. This is a property of the pure carbon graphite. So there is no composition dependence in these parameters. It's also only in the, well, it doesn't show up here. I'm going too quickly.
I think you have the proper ones in the later example on aluminum carbon.
Yeah, but that was okay. Well, this is a kind of full. I'm getting a bit tired talking here. This is a kind of full model description I suggest we provide, so people can really see what is done by. And here you have the tag identifying the model. These are the composition dependent parameters of the model. This is not really needed, but it was the old difference between the FCC and the BCC. The BCC had -1 and the FCC had -3, and the new magnetic model from Ching had 0. So this is the identification of the current magnetic models we have. And I included the functions here. They are also listed when you list the parameters, but it's nice to have them all together. And this is the Einstein function, liquid two-state model. Volume, we haven't really this is just suggestions. I mean, and this is the disordered part, permutations. I haven't really talked about that, but it's let's see if we can have an example here. This is for the aluminum carbon. And I don't think I have changed here because this was sent out before I discussed with Reza and other for the. So here okay, no, here it is you see for the liquid aluminium, you have the Einstein temperature for liquid aluminium. Liquid carbon, and then this is for the temperature selected to depend on composition, the Einstein temperature. But it is actually you see it's a logarithm of the numbers, so the logarithm is the one which varies. But you can still have the fitted Einstein temperature as an argument of this logarithm. And these are the nice functions you can calculate with the new unary. You can get heat capacity down to 0 at 0, and This was the problem with Reiner Schmidt-Fetzer, but when you get too high heat capacity here, that affects also the Kopp-Neumann rule for all the aluminium compounds. So Malin and others are discussing how to introduce a breakpoint again to have a continuous, to have a new value at some 20% above the melting temperature, and then approaching a constant value at high temperature. Or it's not really easy to fit to approach the liquid because the liquid is a rather complex model also now. So not trivial to find well, if you approach 3R, you will go to a reasonable number, I guess. And this is the liquid amorphous transition. It's not the glass transition, it is the amorphous transition, which is fitted with a two-state model for the liquid. And this is what Bengt sent me. So here he proposed the strict crystal structure, a prototype, and you have some problems here because for metals it's the cube copper, which is the prototype for. We also use this basically the same model for sodium chlorides. You have multiple ways of specifying the crystal structure for this FCC phase. And I will talk a little about this disordered. In the current TDB files, you have one description of the disordered BCC phase with 2 sublattices, and you have one with the 4 sublattices where you include the B2, the B32, and the DO3 ordering. But here you have to know which 2 sublattices are actually next nearest neighbors or nearest neighbors. Otherwise, you will not be able to separate the B2 and the B2 and the B32. And that affects also the parameters, because you would have sorry, you will have lost mine now, but if you go down to the parameters here for the BCC phase, if you have permutation, you give this parameter only once, and then the software will take care of that it will be the same value independent which sublattice the lithium is. And for this parameter, you will have 6 variants where the lithium and aluminium are on different sublattices. And this again, you have 4 variants where it will be on, aluminium will be on the different sublattices. And the same for the excess parameters, that this means that you should have the aluminium-lithium interaction on all 4 sublattices, should give this one. For the BCC, you would have one where you have aluminium, aluminium, lithium, lithium for the B2 ordering, and one which aluminium, lithium, aluminium, lithium, which gives the B32. Oh, it's typing error. It should be 32 here. So
there is a mistake there. Yeah, probably mine.
Wow, no, it's probably me. Oh, okay. Well, I don't know. I've been editing this file many times, so it's probably my error anyway. But what is nice here is that at least here you have, what is it, 4, 6, 7, 9 parameters, 8 parameters. If you didn't have permutation, it will be more than 30 parameters you have to give. So this reduces the size of the database a lot. So it's especially if you have higher order systems. And I also added some, well, you can edit comment like this, but as I understand, one can add comments where no, I don't know. Okay, I've also been I will present this tomorrow for the foundation a bit, and I edited a more comprehensive file for them, shorter, where I could, I think if you have a tag like this, let's see, when we have a parameter, T-range, no. Okay, I think basically if you have, as I understand my XML, basically here you have a face which starts and then it finishes down here. That's one thing I like about XML. It's quite clear where the face ends. If you have just a curly bracket, it's the curly bracket is quite insignificant. Basically here, after this greater than comments here, and the XML will ignore it because it doesn't have anything to do with the XML. That this is a new tag starting on and finishes here and so on. So there are, in addition to this kind of comments, you can add comments which are belonging explicitly to this tag here, after the larger than and before the end of the face. Okay, that's what I had planned to explain, and we have had some nice comments, and I will try to work on that. And I'm very happy if I can continue using XML, and then we can discuss how to handle various things with that structure. Okay, Reza, you are also happy?
Yeah, thanks for the explanation. I think I would like to discuss the project plan a little bit more. The language, now we have talked a lot about it, but as I said earlier also, this will still have the same problems as TDB. I mean, if there are mistakes in it, if there are duplicates, if there are tags that are not properly named. So XML language, the default XML language parser will not care about any of the logic or the language that we discussed here. It will only give you open tags and end tags symbols. The rest relies in the software, the parser that reads this language or this database. In Thermocalc, at least now, we don't have any plans to support this because we have spent a lot of time on parsing and checking the TDB language, and after many years there are still new cases that we find every day. But now we have a good database checker and the good database language plugin that can be used in VS Code, and you can parse the TDB as you edit it, and you can reformat, you can rearrange the parameters, you can do a lot with it. So as far as Thermocalc is concerned, we don't have an issue with this language, but we need a converter that does the upload and download outside Thermocalc. This will be, I mean, to support this language directly in Thermocalc will be a big project.
Well, one problem with the TDB file is that there is no way of specifying Einstein model and things like that. So those things you have to modify.
Yeah, TDB, of course, is not the best solution, but this new language will also have its limitations, and most importantly, the XML, as I said, the language doesn't provide any logic check or consistency check. If you have a parameter that is if you have elements in a parameter that is not in the phase model, if you have species that are not defined before, or a lot of things. I mean, a lot of still there are a lot of syntax in this language that is more or less the same as TDB, like the model identifiers, G, parentheses, and what goes in it, and people can make mistakes in there as well. So what happens when you have an XMLTDB that's full of errors? You won't get any errors in your editor, in Notepad or VS Code or whatever you use.
Well, if you have a yeah.
I have some experience with XML file, and actually I did write a very primitive output from the Pandat from inside, output to XML and read XML into the Pandat. But just some very basic one. I spend not too much time on that. Okay, my experience is that we do not use the XML, the parser, to do the logic test on this database, because all the its logic error that should be checked by inside the data structure and algorithm inside the engine part. And for the what I did is I pass the XML into the Pandat, convert that to the TDB format. For example, for the parameter, okay, I will form. I read the parameter, like a G parameter or L parameter from the XML. That may be a few lines. I combine them together into the TDB format and then do the parsing. If something new, the style is not within the TDB, and then we will do a different kind of, we will add on into the parser inside the engine part. So any text file in you cannot avoid that. There's some logic error. So those kind of logic error has to be checked within when you pass into the data structure, and then you do the internal check. That's what I did. Okay, reading the pass the XML into the Pandat, convert that into the TDB style, and then do the parsing. Well, so that to me is not much job.
Yeah, so that's yeah, but in that case you will lose all the benefits of this new language. So everything is again converted to the TDB in the end. It can work as a medium if you have a converter that first reads a TDB in TDB format, checks for all the errors, and converts the parameters or whatever it's in the TDB to the XML free of errors. Then you can read it to another database, in another software. So the checks, the structure checks are done again in the source and destination software in the format that they support. But if they want to read this TDB, this XML TDB directly, then they need to make sure that the data structure in it is correct. And
Yes,
that is not something that the XML provides by itself. You have to have.
For example, for the A-star model, actually right now Panda does not have the A-star model. Okay, and even you have a TDB, you have that. I cannot read that. Panda cannot read that. The same for the XML. So which means when I read the XML XTDB, I will create, if it is A-star model, I will create a new data structure to hold those parameters and do the that gives energy some other property calculation. Yeah. I think that's the two things. One is the XML and the TDB just the readability. Okay. For the new user, I believe the XML is easier to read, to edit. This is one. The other one I had experience is I discussed with boss a few times, and we use XML for the Pandat for this workspace. We found that it's avoid a lot of things. It's no crash. Okay, before we use the binary file, a lot of crash because we save binary file and read that, and it's really hard. But I use XML. Now we use XML for the batch file for the workspace, and it works much better. I believe for the database, I think it's extendability and readability is much better than original. That's my feeling. Yeah.
We also use XML for other purposes in ThermoCalc. I'm not a software developer, but I know that we use it for some parts to transfer the information in our project files, for example, the settings in our graphical unit interface. So we don't have anything against XML itself, but it's, as far as I understand, and I have talked with our software developers, it's just a mean to transfer information internally. If you want to use it directly to edit by database developers, then you will make mistakes. You will make the same mistakes that you do in the TDB, and then the database is useless until you find the errors and resolve the logic issues.
If I comment, the current TDB format, XML format I propose, uses basically the same type of parameter identifiers as we have in the TDB file. I mean, you have the Gibbs energy phase constituents. So if you already have a check from the TDB file that the parameter doesn't include errors in the phase names or constituents, you can use exactly the same software for the check from the XML file as you had from the TDB file.
Yeah,
you don't have to write new code. You have to specify. You extract the parameter identifier, and then you use the same code as you had for the previous checks.
Yeah, to extract is the same as to download or convert it to TDB format, and then you can check with our database checker. But yeah, like you said, many of the syntax is still similar to the TDB, and for the same reason, it can have the same errors. You can replace a comma with a semicolon, or you said, for example, you want empty space between the species in somewhere, but if a user puts a comma there instead of an empty space, then yeah, there's no problem in XML, but then you cannot read this XML with the download or converters software.
I think there's three parts here. One part is the database part. Okay, the read database, the parsing. okay, database, really in parsing. The other part is you convert those parameters into data structure, okay. And then the third part is within the data structure, we do the logical or error check. So those error check or logical error, that has nothing to do with the database, or I mean the text. Okay.
Yes.
Yeah. So if that any error is not because of you use a TDB or XTDB. Okay.
Yeah. I think we are saying the same thing. So the XML or TDB will have the same errors, and then it's to the software that finds the logics or finds the errors. So what advantages do we gain?
I think that we are gaining when it comes to the documentation on the database, like having or thinking in the first time, having a comment for each of the parameters and for the different information about crystallography and so on. This is something that maybe today is not supported by Crystal.
Yes, I agree. I fully agree. And we can,
But
I'm not saying
even
that we should do that, but we can introduce that in the TDB format as well. TDB has a definition, but it lacks a few things like crystal structures or models. You can get rid of type definitions, but the TDB is also a language that has its own definition, the same as this XML definition.
is it something that you're working on? I mean, adding more information. I mean, it's important for the people doing the databases, but it's also important for the people using the results of the calculation at some point. Of course, we are used to handle with the old version, and we manage to do somehow. But there is a lot of information that we are putting in our database that are quite well not taken into account by the software, and at the end it doesn't go to the end user. Well,
Yeah.
if you have something that enables the next generation of TDB, I don't know if it's not XML, if it's a new TDB, that's okay. But the information, well, the points that we have introduced or Dusu have introduced that are new in the format that it proposes are something that I think is important.
Yeah, Use once said that if you prefer something else, you should develop it and promote it. And I agree. We could do that. In Thermocalc, we have tried to modify the TDB format a little bit, working with things that are still in the limits of the TDB to add crystal information or do other things, but we are limited by our legacy code, the Fortran code, and the way that it accepts the information. So even now we have a new core, GES6, and it allows a lot of things. But since it's not completely integrated into all of our modules in the software, we have to comply with the old legacy limits of the TDB and Fortran. And we will have the same situation with this XML. We cannot use all of its good things with software until we replace the TDB language with XML in our software everywhere.
But from my viewpoint, I think that today you will not do it for sure. But if another software does it, then you will have to do it. And if there is a language or a format that is proposed with new features, and at least one of the software does implement it, at some time you will be tempted to do it also, and your customers will ask for it. So that well, the way I see this project, I don't know if it is needed to, but I see it like a driving force to go further and nicer in the field where we are working together for years with the same thing. That's the good point to me, I think, to think again about things that have not been changing for 30 years.
I think one of the advantages with the XML format is that it's relatively easy to add additional structured information like this crystal structure or any other information that is not necessarily read by the software. So the software can decide which things to ignore and which things to actually read from the XML format. That is very difficult, I think, with the TDB format, because the software expects to interpret all tags in the TDB file.
Yeah, I had experience on the XML. For example, the batch file used by the Pandat. I consistently add some new features. I just create a new keyword and then modify a little bit in the program. It works. So its extendability is much better. Yeah, that's I do have experience on the XML. And yeah.
Sorry. Go ahead. Yeah, I agree that it's extendable, but those extensions will only be useful when the software support them. All the software, Backstage, Pandat, yeah, all the Calfat softwares. Otherwise, yeah, you can add extensions to TDB, but it will not be supported in any software.
Oh, we can see that right now we are just we had a lot of discussion at another features into the XML and TDB. So we had a lot of discussion about that. So looks like it's not difficult to add those things in the XML TDB. Yeah, we have seen that.
Well, I think what you should do in Thermocalc is to get rid of guess 5. Yes.
Yeah, we are trying our best, but it has been maybe 10 years, and I think it will take another 10 years to completely get rid of it.
I have a question that is very much, well, for the Thermocalc users. This is something that I've been expecting or wanting for long. The treatment of ordering for several kinds of elements, like ordering of metals together with ordering of interstitials and other sets, like on the kappa phase. Is that meaningful to you, what I say? Nowadays, we cannot do it easily with the software, even for C. Is it something that you're thinking about? Or do you make that the new gas 6 will be able to do that?
I think I lost your voice for seconds, but
sorry.
yeah, we have requests for all kinds of features that can be done in the new core gas 6, but they are on the roadmap. This one I'm not sure. Ordering of interstitials in kappa phase. I know what you're talking about, but I don't know where in our software roadmap it is. But how is it related to XML?
Well,
it's not related to XML. It's just that, I mean, if you want to ordering in kappa phase, you have to have 8 sublattices, and 4 of them can have FCC ordering, and the other 4 can have FCC ordering. I don't think that is within the next 10 or 15 years. Sorry.
No, but the point is that the way that we are dealing for ordered phases, for instance, like I've been doing this in my PhD or later on, that was not something that was considered at all at the very early time of this sublattice formalism. In the early or in the late 70s or in the late 80s. It takes a lot of time to set up a software that will work for 40 years, 40 years. I don't know. If you don't think at the very beginning what will be needed or what could be needed, even if it is not needed today, you will miss some of the interest of the software that could appear within 10 years.
Yeah, the better you think and plan in advance, of course, it saves time.
That's the point. It saves time. I mean, at some time when we were working on the TCNI, I wanted to have a course of lattice for BCC working properly. It took very much time to debug some things that were not working in the early versions. Nowadays, actually, there are some materials where ordering on BCC lattice becomes to be interesting at the level of the materials. I'm not sure that today the software is actually able to handle that efficiently.
No.
And this was a need that was expressed almost 10 years ago, 20 years ago, and still it's not really fixed. But now the need is more intense than it was 20 years ago. If you don't think today about the need that you will have within 20 years, you could be behind the other ones within 20 years. Well, maybe for myself, within 20 years, I will not be anymore in the business. But you are young, Reza.
Yeah, but I'm not responsible for thermocalc, especially software.
No, but it's well, to continue I'm not sure that Husserl, when he was writing the early Guess 5 version, would have think that he would have been working with it for so long.
Yeah, I think now we're talking about the slow progress of thermocalc, but we have our reasons for it. But about this ordering, for example, now we now added checks to make sure that the sum of ordered sublattices is the same as the one in the disordered part. So you can have, before you could have 0.25 or 0.35 or point anything, but they didn't add to 1 for FCC or BCC. And these are things that need to be checked in the XMLTDB format as well. But there is no place in this XML format now for these kinds of checks.
Well, the XML format will only provide you with consistent XML information. What is in the attribute information, your software must always check. I mean,
yeah.
And but as I understand, it depends a bit how you program, of course, but I mean, basically you have exactly the same information in the XTDB file as you have in the data in the TDB file today. I mean, it's just that you put the checks at slightly different. You extract information from the database file and then you check it in the same way as you do for the TDB file, but you will not read the same, you will have not read it from the same part of the database. That's and I mean, if we keep the parameter description exactly the same, checking of that a constituent actually is a constituent is the same thing as you have for the TDB file in that, from the parameter. And I agree. I haven't thought. I mean, when you read the constituents for the pace, when you in the TDB format, you can have a comma or a space between each constituent, and you have a colon between the sublattices. Now you will read each sublattice as a separate tag, and if it's a comma or a space between the elements, doesn't really matter. I would try to enforce that one use only a space. Commas are a mess, but that can be handled with the same part of your own TDB checker. I mean, that's not a problem. You have to reorganize the way you read from the XML file, but you can use the checks already existing for the TDB files. And I think when you add information from a publication, you can find a lot of mistakes. But when you already, I mean, the TAF ID database is about 50 elements, 45 elements, something like that, and then I can read all of that into OpenCalFA, and then I get all checks done. That if there is a parameter which has elements which doesn't exist in that phase, you get an error. You can use OpenCalFA to check the database.
Yeah, so that was my question. Where is the download software in this project? Is it going to be open?
Yes, my idea is that we should have a GitHub page, like Fabio showed for this mathematical expression. Great. I will talk to SGTE that they should set up a GitHub page, and initially I can try to take care of providing basically some software for checking, and well, if you want the software, that can be Fortran. So of course, that's not so nice, maybe. But
I want to get back to a point again about that ordering and stuff. Like today in ThermoCAD, where I enter, so one of the nice points in that XML is, for instance, that we make clear the differences between the two terms, compound energy formalism, and the three terms, compound energy formalism. Today in ThermoCAD, when we set up the TDB, it's clear what is the version. When we list the description of a phase, we are not able to see which of the one we are using.
Yeah, but that's just the listing.
That's just the list, but that's, I mean, when I'm using a description of a phase, I want to be able to see what has been, well, I want to be able to check that what I input
I
in the
understand.
software has been properly understood by the software. If it is not able to list different options, how can I be sure that it has been properly understood?
I understand your point. I will add it to our wish list if it is not already there. But if you read an XML in ThermoCAD, you can still list it without that information. So
okay, we are just trying to make very clear some points that are not clear today with the current TDB version.
That information is clear in the TDB, and it's clear in the XML. But when you go to ThermoCAD and you read the output, it's not clear. That's the user-friendly part of ThermoCAD, which is not good. But that's not part of the TDB format or XML.
No, it's once again a lot of little details that are present in the TDB or that will be then in the XML, that are information that have been given by the software, by the database developers, that is lost when getting to the software. And
yes.
if it is clear, well, if we do a publication and explain all what you can put in such kind of databases that actually do not tend to the end user of the calculation. There will be at some point the driving force to go towards more information to the end user. Well, I think that's the sense of the history. People want more and more information, documentation about what they are using.
Yeah, I fully support that. I just think that XML doesn't solve this issue. We can solve it in the software if there is time and priority. That's the software part. That's the application part.
Yeah, the point is that if each of the software solves its own issues and learning on its side, then there is no need to have a common software or common format that will allow people to see the advantage to use one or the other one. And of course, it is not your job. I mean, the job of the Pandat or Thermocalc or MatCalc or OC people. OC does want openness, but for the people that are selling the software, of course, they want people to use the more as possible their own software. It's not the game to make it easier for the end users to compare between the different software. But for the academic field that are working these aspects, they do want to be able to do that. So maybe the companies are not interested in it, but it's nice that there are some people that are interested in this possible bridge between the different software.
Well, I think we have had enough for today.
Yeah.
This has been very exhaustive discussion. I will try to. I'm not sure I will be able to make a summarizing tomorrow, and I don't think we will have such a long meeting tomorrow. But tomorrow morning I will have actually a meeting with the foundation for the thermodynamical, who is actually sponsoring this project, and I will give a short summary again for this discussion. But what I'm very happy with is that we can start working with the TDB format and find the ways to make it much better than what I have just sketched in the presentation today. And we have discussed some issues which has to be solved, like this wildcard thing and things like that should be handled more, well, either software independently or at least provide an information how one should convert from one way to another way and so on. And with that, I would like to thank, well, many of the participants has already left, but anyway, thank you who has been all here, and thank you for those who has already gone to bed or gone to work. So
thank you so much.
I hope to see some of you tomorrow, and it will be a very short meeting tomorrow, I think, because we have already made a long list of things I should work on. Okay.
Okay.
Thank
you very
Have
much.
a good day.
I will not
Bye.
be
Have a
able
good
to
day.
come tomorrow,
Bye.
so bye
No,
bye.
See you next time.
I understand.
Okay.
Goodbye
Thank
to all of
you.
you.
Thank you.
For joining us. Bye.
Oh, where do I?
Okay.